right? So momentum, like velocity, is a vector quantity since it has both magnitude and direction, right? So just I told you guys in the first chapter, right? The momentum is equals to mv. Yes, Ruba.
Sir, I won't be able to give the test on Friday because I'm having my monthly assessments.
Okay. ठीक है चलें, we'll see it out, figure it out, ठीक है? Okay. Don't worry about that. So momentum is equals to basically mass into velocity, right? So what, since we came to the conclusion that in a formula, okay, so what do you have? You have mass, which is scalar, right? And then you have v, which is velocity. Okay, so if any of the quantity in your formula is, sorry, velocity volume is vector, the velocity is basically v and it is a vector quantity. If any quantity in your formula is vector, therefore the quantity of which we are finding the formula also is becomes basically a vector quantity over here, right? So momentum also has basically two things. It has magnitude and it has direction, right? This is pretty important. Okay. So vectors cannot be added by ordinary addition. So we would have to use basically uh make sure okay they are in the same direction, right? We have done this. How do we add forces? If we have a, let's say, a point mass, let's say if we have force in this direction, okay, F1, and if we have F2 in this direction, how do we find the resultant force? We have done this before, right? So similarly, I'm going to talk about some momentum. How do we basically simplify it out? If they act in exactly opposite directions, such as east and west, okay, like these over here, if you can see the example. So F1 is on the east and F2 is acting towards west. The smaller subtracts from the bigger, okay, and they can, or if they are same, they cancel out, right? The momentum is conserved in explosions, such as when it occurs in a rifle, right? So let me just give you an example. Let me just give you an example. Okay, what is happening over here? I want to see this. Okay. Okay. So now if I add a blank slide over here, so you might have seen fireworks, right? So what happens in a firework, right? Let's say this is the rocket over here, right? This is the rocket. ठीक है जी. Initially it has basically it has chemical stored, right? It has chemical stored inside it. It has chemical stored inside the rocket, right? ठीक है जी. So if I want to find the momentum of the chemicals before explosion, ठीक है जी, before explosion is going to be basically the mass of chemicals times the velocity of chemicals, right? The initial velocity of chemicals, right? Let's say the mass of chemicals is mass of chemicals. मुझे value की I don't care about the value, but you can see that when the rocket is flying, are the chemicals moving inside the rocket? Let's imagine मैंने rocket को fire किया, right? The rocket is basically going up, but chemicals are stored inside the rocket, right? Until after a certain time, then they basically spread out, right? As fireworks. So initial velocity of the chemicals is basically zero, right? Because they are inside the rocket, they are not moving. Okay, when the rocket is initiated, right? So the initial momentum of the chemicals inside the rocket is 0 meters per second, right? So now here comes the question: K, before explosion, the momentum before collision is basically before explosion, right? Before the rocket's firework starts is zero. But how does when it goes to a certain height, like the fireworks start, right? What how is the energy being transferred to chemical, right? Because we want to make sure the momentum after explosion should also be zero, right? So there should be some mechanics, some basically principles, depending upon which my momentum after explosion is also coming out to be zero, right? So let's see it out. Okay. Now basically this is before explosion, right? Now let's see after explosion what happens. So imagine these are the chemicals. One chemical is going in this direction, the other chemical is going in this direction, right? And this is the rocket, which basically is which was carrying chemical, right? And now chemicals are starting to spread apart. So this is basically one chemical goes here. Similarly, the another chemical of same mass goes over there, right? Similarly, it goes over here, it goes over here, right? So this is, let's say, mass 1, this is mass 2, this is mass 3. So similarly, we have mass 3 over here, we have mass 2 over here, we have mass 1 over here, right? So you can see that after explosion, same amount of chemicals basically disperse, spread out in opposite directions, right? So let's say M3, one part is going here, the other opposite part is going in opposite direction. The M2, one chemical part mass is going in this direction. The same mass is going in basically opposite direction, right? So imagine it has speed of, let's say, V2. It also has the speed of V2, right? So let me just talk about this, right? This was because it will be simpler to understand, because it seems like a chemicals are moving in x axis, right? That is this. Okay, that is moving in positive x or negative x, right? So if you just find out the momentum after explosion, that is going to be as follows, right? After explosion, that is going to be as follows. That M2 V2, the V2 is going to be positive because this is on the right direction, and this velocity is going to be negative because it's going in this direction, right? Plus M2 into negative V2. Okay. So the momentum after collision is going to be 0 Newton second also, right? Because momentum is also vector quantity. So particles spread out uniformly in opposite direction, right? So this is one pair, this is another pair, right? And we have another four pair which is this, right? So particles are spreading in opposite directions with same velocities, okay, which makes sure here your final momentum after explosion is also coming out to be 0 Newton per second, right? So if this part makes sense, give me a raise of hand. This just an application, right? Just an application of conservation of momentum in explosions. Does this part make sense? If yes, give me a thumbs up. Okay, it makes sense to Hamza. What about Mashal and Ruba?
Sir, can you explain it again for me?
Okay, so I'm
The
just
after collision part.
saying, is this part clear? This equation.
No, sir, not
Okay,
quite.
so just imagine that I'm talking about this side, okay, this part of chemical spreading, right? So यहाँ पे हो क्या रहा है? यहाँ पे some particles, some mass is going in this direction, and some mass of chemicals are going in this direction, right? So it has a V2 over here. It has the same speed, and the mass which is basically spreading around of chemicals are also same, right? M2 M2. So imagine if you want to apply the formula of sum of momentum after collision. So that is going to be as follows, right? So what is the formula of momentum? Momentum formula is mass is equals to what? Momentum is equals to mass times velocity, right? I'm just doing that over here, right? So M2 for this particular part, and this direction is positive, so the velocity is positive v2, right? Plus this this part of the explosion, that is m2 times the velocity is negative because it is going in the left direction, right? Times negative v2, right? So if you add them up, they becomes what? This is m2 v2 minus m2 v2, right? So what is m2 v2 minus m2 v2, Mashal? It's going to be
Zero.
0, right? So similarly, this is happening in this direction for the orange pair. Similarly, for green pair, it is also happening here. Okay. In every direction, the net, if you sum all of them together, you're going to get a sum of 0 Newton second after explosion, right? Does that make sense now? Okay. So this is how rockets are designed. And you would be thinking, right? Initially, अगर momentum 0 है, so how are they exploding? Okay. So they are basically exploding in such a way that if you sum all of the momentum, since momentum is a vector, so some side would be positive, some side would be negative. Okay. So if you add it up, you get a net value of 0. Okay. So this is now, let's do an example of rifle, right? So rifle, what is a rifle? I believe everyone does play PUBG or any games which basically include guns, right? So this is a bullet over here, right? So this bullet has a mass of 0.01 kg, right? And it goes in this direction, right? With a velocity of 300 meters per second, right? So now let me just go back to the content over here. So before firing, the momentum was, so before firing, the total momentum is zero, since both rifle and bullet are at rest, right? तो बिकॉज बिफोर फायरिंग बुलेट भी अंदर है, बेसिकली राइफल के अंदर है, और राइफल भी मूव नहीं कर रही है, सो द वेलोसिटी ऑफ बोथ ऑफ देम आर जीरो, सो देयरफॉर द मोमेंटम इज जीरो बिफोर firing, right? During the firing, the rifle and bullet receive equal but opposite amounts of momentum, so that the total momentum of the rifle is also zero. ठीक है? So similarly, let me just draw a diagram. Imagine this is your rifle. ठीक है जी? And this is your, let's say this, and you are basically firing it, right? So when it is being fired, so obviously it has some certain mass of gun, and this has some mass of the bullet, that is 0.01 kg, right? And this is basically moving with the speed of 300 meters per second. The bullet, right? And it is going in this direction, right? So if you have noticed some educational videos about how to fire a gun, you would see the bullet, there is a jerk on the hand of the fireman, right? So the rifle basically will have a force, a certain momentum in this direction also, right? Okay, that is going to be negative V gun, right? So let's find the momentum of the gun after firing, right? So let's find the momentum of the bullet after firing it. So after firing, what is happening over here? So the momentum of the bullet is going to be as follows. That is mass of bullet times the velocity of bullet, right? So the momentum of bullet is going to be equals to what? That is 0.01 times 300, right? So what is the momentum bullet coming out to be? It's going to be 30, right? Sorry, 1 upon 100 is going to be 3 Newton second, right? So this is the moment of the bullet after the basically the firing over here. Okay, so what happens over here is as follows. So what is happening over here now? Can you explain if you use the principle of conservation of momentum, right? So the momentum which is transferred to the gun, right, that is momentum of B, is also transferred equally back to the gun also. Okay, that is going to be momentum of gun, right? So using principle of conservation of momentum, since before collision, before firing, right? So before firing, the total momentum was 0 Newton second of the gun. This is a combined momentum basically of the gun and the bullet, right? ठीक है जी? Let's say before firing, this was the case over here, right? So this is your gun. ठीक है जी? And the bullet is also here, right? Inside the gun. So they both are at a velocity of 0, right? If you apply the formula of momentum before firing, that is going to be what, right? Mass of bullet times velocity of bullet plus mass of gun times velocity of gun, right? Both velocity of bullet and gun are 0. Therefore, the momentum before firing comes out to be 0, right? ठीक है जी? Now, to basically make sure that your principal conservation of momentum is correct, that says K momentum of before firing should be some should be equals to sum of momentum after firing, right? So the left side is 0. So you want to make sure that the right side should also come out to be 0, right? So for that, I want this to be same, right? Because since it is going to be positive, it's going to be negative, right? If you want to find the total momentum after firing, that is going to be plus momentum of the bullet minus momentum of the gun, right? If they both are same, this is going to come out to be basically what? 0 Newton second, right? And this will basically make sure that my principal conservation of momentum is applicable, right? ठीक है जी? So using this assumptions and principles, the momentum of gun should also be basically be 3 Newton second, but it would be in opposite direction, right? Make sense? If it makes sense, give me a thumbs up. Makes sense to Mashal. Okay, good. Makes sense to Ruba. Okay. Thumbs also. Acha ji. So now let me just give you an example. Let's say the mass of the gun is, let's say, 0.8 kg. ठीक है जी. So let's find the velocity of the gun after firing it. So we know that the momentum of gun should be 3 Newton second, right? So now we are also given the mass of gun is 0.8 kg, right? It's 800 grams. Okay. So let's find the velocity with which the gun would move in this direction, right? The velocity of gun, right? Okay. So that since momentum of gun is equals to mass of gun times velocity of gun, this is 3 equals to zero point 0.8 times velocity of gun. So what is the value of velocity of gun coming out to be? 3 upon zero point 0.8. It's 30 upon 8. What is the answer in decimal points? It should be meter per second. 3 upon zero point 0.8 is what?
3.75 meter per second.
Yeah, that's good. It's 3.75 meter per second, right? So what would happen? So let's say if you're holding the gun with the hand, okay? So you would also basically have to apply a certain force to overcome this, right? Because that's why you have a jerk when you fire, right? Okay? Because the rifle is trying to move towards you with a velocity of 3.75 meter per second, right? So yeah. So rockets and jets. Can you explain this? Can you explain how do we basically lift the rocket into the air and make it leave the sky? So you can see here there is some fuel over here which is basically going in this direction. Okay, this is the velocity of fuel, right? And this is the velocity of the rocket which is going in this direction, right? And let's say rocket has some mass which is, let's say, mass of rocket, and the fuel which is coming out is also certain mass, that is mass of fuel. Can you explain me using conservation of momentum that how this phenomena is making the rocket to be lifted from the earth and accelerate toward the sky? It's pretty simple, right? If you want, I want any one of you to answer. Otherwise, I will call someone out. Yes, just give me a guess or your ideas. We have just discussed this idea using the principle of momentum in rifles.
सर
Yes,
एक दफा क्वेश्चन वापस पूछिएगा बताएगा.
I'm just saying कि रॉकेट जब बेसिकली लिफ्ट हो रहा होता है, ठीक है, सो यू नो कि हमारे पास एक कुछ वेलोसिटी है फ्यूल की जिससे फ्यूल रिलीज हो रहा है एंड कुछ वेलोसिटी है रॉकेट की जिससे वो ऊपर जा रहा है. इट्स बेसिकली एक्सेलरेटिंग इट. So, how is principle of conservation of momentum is applied over here in this example, which is causing it to accelerate?
सर इसमें जो फ्यूल की जो वेलोसिटी है और वो मोमेंटम जो है जो रिलीज हो रहा है वो एग्जैक्टली सेम होता है उससे
Good.
जो रॉकेट जिस फोर्स
Correct.
से ऊपर जा.
Perfect. So what is basically the output of this? इसका बेनिफिट क्या है फिर? लेट्स से हम उसको फ्यूल रिलीज कर रहे
रॉकेट स्ट्रेट लाइन में जाता है एक.
हैं. ओके. परफेक्ट. परफेक्ट. गुड. ठीक है. That's good, right? So just imagine the beauty of moment, right? So we are applying this in creating rockets. ठीक है. So what this is basically, let's say initially what was the scenario? The rocket was stationary, right? Let me draw a good rocket. ठीक है. The rocket was stationary. ठीक है. It was standing. ठीक है. And this was fuel. Everything was stationary, right? So let me just find the momentum before launch, right? So the momentum before launch, right? BL. So BL stands for before launch. Okay. So what will be the formula for this? Okay. It has some certain fuels also. Okay. Fuels are here. Okay. Let me draw some using some highlighter. So these are fuel tanks, right? Which is going to be releasing fuel, right? So it has some mass of fuel, right? And it has a mass of rocket over here, and initial speed of fuel and initial speed of rocket, right? So since it is at rest, nothing is moving. So the initial speed of fuel is equals to initial speed of rocket, that is zero, right? They both are at rest. So therefore, if you apply the formula, that is the momentum before the launch is equals to basically the mass of fuel times the initial speed of fuel plus the mass of rocket times the initial speed of rocket, right? So if you apply this, the see the values and this, what would happen? The momentum before launch is going to be mass of fuel times zero plus mass of rocket times zero. Therefore, the momentum before launch of the rocket is 0 Newton second, right? Now, using principal conservation momentum, it says here the momentum before launch should always be equals to momentum after launch, right? That is, it should be 0 equals to 0, right? Now you want to make sure that this condition is getting satisfied, right? Now, this case is basically after launch, right? The rocket is accelerating. Okay. So the fuel is basically moving with the same speed as the rocket is accelerating upwards, right? So if this is positive and this is negative, right? Direction, since velocity is a vector quantity, it would have positive and negative direction, right? So if I talk about y-axis, this is positive y and this is negative y, right? So the up direction is positive and the downward direction is going to be negative, right? So now let's apply the equation after launch, right? Let's see what happens after launch. Okay, so let me now insert a blank slide over here. Okay, so now if you apply the equation of momentum after launch, that is going to be as follows, right? That momentum after launch is going to be what? It's going to be mass of fuel times the final speed of fuel plus the mass of rocket times the velocity of rocket. Okay. Since you can see the direction of final velocity is downwards, sorry, the fuel is downwards, it's negative. You can put a negative sign here, right? And the rocket, the velocity of the rocket is positive. Okay, so it is positive. Okay, since it is moving with basically zero acceleration, that means the vr is equals to vf. Okay, so these both quantities are same, let me call it as v. Okay, दोनों की speed की magnitude same है. ठीक है, v can be 10, 15, 35 meter per second, whatever the value is, right? So since the both are same, okay, so you can just substitute the values. That is going to be mass of fuel times the negative v. ठीक है जी, so negative v plus mass of rocket times v, right? अच्छा जी, अब mass of this is the rocket is designed in such a way that the mass of rocket is always same as mass of fuel also. ठीक है, so since they both are same, they cancel out, and this would basically give us again what? The mass, the total momentum after launch is also coming out to be 0 Newton second, right? So जितना basically mass of fuel save किया है in the rocket, उतना ही basically mass of fuel होता है, so that they cancel out each other and you get a final momentum of 0 Newton second. That basically makes sure that your sum of your principle of conservation momentum is getting applied, right? Is it clear? If it is clear, give me a thumbs up. Just an example to make you basically realize how our rockets launched, right? How is momentum used over here? If it makes sense, give me a thumbs up. It makes sense to Ruba. What about Hamza and Mashal? Yes, are you here? Okay, makes sense to Hamza. Mashal, are you here? Okay, ठीक है. So now it's just, let me just quickly skim through it. Okay, what are they saying? So if you release an inflated balloon, okay, with this neck open, okay, it flies off in opposite direction. Right? You might have seen the experiment. आपने balloon को expand किया, and if you release it open, so basically the air is going in this direction. It causes the balloon to accelerate in this direction, right? So this is again an idea of application of momentum, right? So in figure 1.6.3, air has momentum to the left, the balloon has will basically moves to the right with equal momentum, right? Okay, to basically make sure that the sum of momentum is always same, right? This is the principle of rockets and jet engines. In both, the high velocity stream hot gas is produced by burning hot fuel, and it leaves the exhaust with large momentum to basically make sure that the rockets accelerate upward, right? So again, it basically gives the rocket an equal forward momentum, which causes the rockets to accelerate upward, right? Which we have seen in the example, right?